When it came time to look at my Commodore 64 power supplies a little more seriously, I felt that it might make more sense for me to figure out how I could fix or at least augment my existing power supplies on the cheap. And after doing so, I thought, well, I can't be the only one interested in doing this. So what I used to do, following the guidance on the C64 wiki, was to test my power supply yearly. They gave a nice chart of what conditions a loaded power supply should be operating within and when to replace it. So I went and built myself really just a simple power supply adapter that I could plug in, get a DC output on, take that DC output, connect it to some power resistors, stack 3 of them together, you get 3.3 ohms, and that sucks about 1.5 amps off of your power supply. So ran that every year and hey, hitting right around 5 volts on the dot. So I thought I was in reasonably good shape. I stumbled upon this article on the Lemon 64 forum where they talked about the Commodore Brick of Death, and their notion was that really none of the tests that you could do on your power supply will ever confirm whether or not the thing is just going to die in the middle of nowhere. And that's a pretty frightening notion. The 5-volt rail is going to explode at any moment, and it's going to overvolt and kill your C64. So you got to fix it. So one of the primary reasons that the 5-volt rail on these power supplies died so much is because the whole power supply itself, the innards, was potted. It was filled with epoxy. And this covered everything, including that poor 5-volt voltage regulator that was trying to step down that 9 volts that it was being fed. It just had nowhere to put the heat. But you could see that, obviously it's 100% unrepairable. All the innards are just cemented inside of this tomb. So what I did is I went on Amazon and decided to try to source a cheap 5-volt supply first. And I don't want to put any links to anything or you really note any particular power supply as fit for purpose. I was able to find one very cheap that seemed to have good reviews, and someone had taken it apart and said that it seemed to have been built electrically safe. Now, the one that I have, when I opened it up, did not have the same schematic as the one that was taken apart here, so fingers crossed they actually built it even better than the one this person had disassembled a few years back. But in general, it seemed to be decently well built and was capable of 5 volts, 2 amps, so well within specification. So that's where I sourced the 5 volt from. All the documentation I could find on the internet said that the AC rail really never goes bad. It's kind of good forever. It's really just a transformer. If a transformer were to fail, it's rare that it would go into an overvolt scenario. So why would I want to go and source a new 9 volt if I could just keep the existing one that I got? So I went and just started to pry open the C64 cable. And what's nice is that I found in a lot of the cables is that the DC lines are color coded, where brown is your hot and blue is your ground, and that the AC lines are black. Now, not always 100% true, but in the case of the C64s, the 2 that I ripped open, that was the scenario. And so after identifying those and validating all the stuff with the multimeter, both on the tip that goes into the C64 as well as the wires coming out of the original power supply, confirmed in fact what was what was the hot and what was the ground. And then I ripped them open, split them open, and I heat shrinked off the existing 5 volt coming from the power supply, and I bared the wires, and then I soldered in directly into the cable hanging off the side the wires from my 5 volt power supply that I sourced on Amazon. So just soldered those in, heat shrinked it all over a couple times, and then electrical taped it all up. So there's 2 plugs. You got to plug in 2 things in order to run this power supply. But now I've got a 5 volt rail that I feel a lot more confident in. So I built a small adapter that taps into the tape port and feeds just the DC voltage that the Commodore sees to a pair of wires. And then all I do is I just attach a multimeter to those wires, and that tells me what 5 volts is as seen by the C64's internals. And this is a great way of just getting a quick litmus test to make sure everything is good. So with my 1541 Ultimate on my C64C, I'm seeing about 6 watts being pulled from the 5 volt supply on the wall. And we know watts stay constant regardless of how much transformation is done. And so 6 watts coming out of the wall means 6 watts going into the C64 more or less. So with my power supply measuring 5.07 volts as seen by the internals of the C64, 6 watts coming out of the wall, we can surmise that the 64 with the 1541 Ultimate is pulling about 1.2 amps. And that's, again, delivering 5.07 volts. When I remove the 1541, it's pulling a little less. I can see voltage raise up to about 5.12 on the internals of the C64, which is still well within spec. So for under 25 bucks, I was able to fix this power supplies on both my VIC-20 and my C64C. So the power supplies now on my entire Commodore fleet are operating within safe margins, and I expect them to keep operating that way well into the future as they're using switch mode power supplies. And so even though I really don't know how long these things will last, the fact is that now I've got a solution for them. I can simply replace them with new switch mode power supplies in the future for just as cheap, and I can keep these things running in a safe condition, or presumably safe condition, well into the future. And that brings this short video to a conclusion.